So, in this video, we are going to solve a transport processes problem focused on convective mass transfer. The problem is the following. In the reagent warehouse, benzene was accidentally spilled into a 5 meters long by 4 meters wide room, forming a uniform layer 3 milliliters thick with the shape of a rectangle with 2 long per 1 wide meters. Unfortunately, due to a cut in the electrical supply, the warehouse extraction hoods cannot be activated. To help the removal of benzene in the room, it was decided to open the doors. Because we are in one of the windiest days of the year, air flows at 2 meters over second. Air flows over the length of the room. The temperature is 18 centigrade and the pressure is 1 atmosphere. With the help of the diffusion coefficient calculated in a previous problem, we have to calculate the following: the Sherwood and Smith number for this case, and V, the mass transfer coefficient. The assumptions for this problem are that we are in a steady state. Temperature, pressure, and diffusion coefficient remains constant, and benzene is evaporating. As we can see in our picture, this is how our problem looks like. However, we have to consider that the doors are open. For solving this problem, first we have to calculate Reynolds, but we have noticed that we don't have viscosity at that temperature in tables, so we have to interpolate. Interpolated, our kinematic viscosity has the value that we can see in the picture, and doing our calculations, we have that Reynolds is turbulent, but we have to know if in some point there is a Reynolds laminar. So we use the same relation for knowing at what longitude is laminar, and we have that at 0.9984 meters our Reynolds is still laminar. That's why we use the Sherwood formula in the last calculation of this page. As we have seen, in that Sherwood formula we need the Smith for knowing the value of Sherwood. So we calculate the Smith with the viscosity, the kinematic viscosity, and the diffusion coefficient. And this gave us a value of 1.8. Then we proceed to calculate Sherwood. That gives us a value of 929.8. Then we proceed to calculate the mass transfer coefficient. That is related with these values, Sherwood per diffusion coefficient over length, and this formula gives us 0.384 centimeters over second. And with that value, our problem has finished. As a conclusion, we can say the following things. We think that our result is viable. Nevertheless, the assumption that benzene is evaporating perhaps is not possible because the vapor temperature is higher than the one we have. The problems we faced was to find an application to our problems that were not mentioned in the problems we did in the school and also in the homework. It was a little difficult to find a compound to work with the properties we have as well. Furthermore, we can notice that these topics apply in several situations, like a simple accident in a laboratory or a reagent warehouse. Finally, we have realized that creating problems is a strategy in which you could understand better a topic than solving it for some people. Well, thank you.